Everyone, welcome back to my YouTube channel. Today I'm doing another mock interview. This time I'm doing it with a good friend of mine, Peter. I lead a club ACM with him. We go way back. And yeah, today we're going to be doing a technical interview, preparing for his Uber interview that's coming up. And yeah, say hey, Peter.
Yo, what's up? It's great to get to, do a mock interview with you. I'm super excited.
Let's do it. Awesome. So I'm going to paste the problem inside of the editor that we're in today. And
Mhm.
then, yeah, I'll give you a few minutes to read it, clarify, do whatever you need to get set up. And then we can just dive right on in. So, have
Sure.
you set up the language yet for this? Or are you going to be using Python?
Yeah. I changed it to Python and I got all the hotkeys and stuff set up that, I want to use. I'm not a Vim pro, so I just left it as Sublime
Cool, cool. So I'm just going to paste the problem directly in.
for sure.
Okay, that pasted terribly, but we can use some doc strings if that is a thing in Python. Okay, yeah.
Yeah, there are, yeah.
Cool.
Okay.
And then I'll just
Yeah,
give you a
take
few
a minute.
minutes.
Awesome. Yeah, I'll just read it real quick. Okay. So I'll be giving giving an integer array height of length n named heights. There are n vertical lines drawn such that two endpoints of the ith line are I0 and I at heights I. Find two lines that together with the x-axes form a container, such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. For example, we see okay, so we have heights, and then the height at index 0 is a height of 1, and the height of index 1 is a height of 8. And just to confirm, like, when it says you cannot slant the container, that just means that there's like no horizontal lines or every line is just going to simply go vertical.
Yes, sir.
Cool. Okay. And so the output here is 49 because the above vertical lines are represented by the array. In this case, the max area of water, or I guess what would be drawn in as blue, is 49. Explanation is because, let's see, there has to be like two values in here that must multiply together to be 49. Let's see.
So essentially, you're getting the bounds within the container. So in this case, if I recall correctly, it would be 7, and then you would also put it at the 8, and then everything within that
Oh,
would be 8 or
I
49.
see. So just to confirm, like in that case, it would make sense because 7 to 8, which I assume the 7 at the very end and the 8 at the very beginning, the first 8 we encounter, those two have a distance of whatever, n length of n is -1, -1. So whatever the distance between the two of them are times the lowest one of them height, which is 7. So we're trying to find the area within the where we make up, if that makes sense.
Exactly. Yeah. So
Awesome.
yeah, we don't really
Oh,
have access to like a whiteboard or anything, but if you want to draw it out to help, I can also help you with that too, so we can like
okay,
visualize
yeah.
how it looks.
I think this makes sense. Like I can try my best to draw it out, but like with like these markers or something.
You don't
But
have to if you don't
I,
feel comfortable.
okay, I mean, I can just kind of verbalize the understanding I have of this question. Um,
Perfect.
so what it seems to me, right, is that we need to find the largest area of a container, right? Because we know that what we're looking for here is basically the container, and what they're looking for is the container that holds the most amount of water. So in that case, we're looking for area. That we kind of can take that from that hint, from that sentence.
Yeah.
And so the way we can figure that out with like the most amount of water is, I think what we could do is we could kind of take a like almost like a two pointer. Like, I don't want to call it a sliding window because sliding window implies that you start from one end and go to the other. I'm thinking two pointer, and the reason I say that is just because, like, immediately when I look at it, I'm copying and like kind of moving this just to visualize my thoughts.
Yeah.
Is
Perfect.
I was thinking, like, what if we kind of had like this, like, approach to it where we know that our best case scenario, what if both of the ends have the most amount of like height, right? So everything in here is the correct like answer, but obviously that's not the answer for this one, but this is just like a hypothetical, right?
Yeah.
Well, we could treat it almost like a greedy solution where we keep like a maximum result, which is like easily just taken as like what's the current max area. And obviously the area, we can calculate that pretty simply by like the area is just equal to the base times the height. We learned that pretty early on, I'd imagine. So right, and the height we know is just whatever the minimum of the left and right are, right?
Exactly.
So first off, left is the lowest in our first case, right? So we know that's 1 times whatever the height, whatever the difference between right and left is +1, right? Because we want to find the amount of elements between them. That's at least what I imagine it is, right? Because that's how we find the amount of distance between two two indices, including like inclusive, if that makes sense, because it's obviously starting at 0. So we want to do right minus left +1. So from there, it's pretty much just a matter of continuously moving in the left and right pointer to find a new possible maximum. And I think that's where it kind of comes in, like figuring out which one to move to find the maximum. And I think this one makes sense if we do it like a kind of like simplistic way. I mean, this is kind of like I'm overcomplicating it. What I mean to say is let's move these left and right indices towards the center based on whichever one's lower, I think. And obviously there's a case, what happens if they're equal, right? What happens if they're equal?
Yeah.
Well, then you'll just default to one of them. So maybe we could just say, while, like if, we'll say while they're not overlapped, while like left and right are not equal to each other or overlapped, we'll just keep moving one of them closer if it's lower. Like we'll say if the left one is lower than the right one, move the left one in. And then if that's not true, we'll just have an else case, in which case right will always move. So that means if they're equal or if right is less than left. That's kind of complicated speaking out loud, if that makes sense. So I can write out some like pseudocode just to write it down to make sense, unless you understand what I'm going for.
Oh yeah, that sounds good to me. The intuition makes sense. I like how you're
Awesome.
using the current heights to determine where you should move the pointers. That sounds pretty good to me.
Yeah, I was gonna say, like, I realized pretty quickly that something I wasn't doing is explaining, like, why we'd need to do that. And just, like, to explain, like, my thought process, I was thinking we move the pointers to whatever is larger, or, like, not whatever is larger, but we move the pointer that's smaller than the other one, because our goal is to maximize the height, right? Or not the height, but I mean, it is to maximize the height, but the goal is to maximize the area, right?
Yep.
And so we never would want to move the larger height, because if we move the larger height, that would be like kind of, detrimenting us. We know that at that current moment in our greedy mindset, that is the maximum value. So we never want to get rid of that until we have a new maximum value that we could possibly, use, and then replace that current lowest value with a new one. For example, like when left gets shifted over to 8, and then we see that right's at 7, we know right's now the smallest value. So to potentially increase this height anymore, we'd have to move this right pointer inwards, and obviously we'd get to 3, and that wouldn't be more, but we'd get to 8, and that, it's still not more, but it's larger than 3, right? So now we're at that situation where left and right are equal to each other, and because of our statement that we said earlier, we would just default to moving right in anyway.
Perfect. That.
Awesome.
Thank you for clarifying that to me too, as the interviewer. That I love it.
Awesome. I just want to make sure like I'm being clear about why I'm doing this, and not just like, oh, I'll just do this because I said I would. I think it's important to be clear about like why you're doing something, or they won't. I mean, from personal experience, I've had people who don't say anything, but then later on will comment that it's not a good thing to just say stuff without explaining, and they won't stop you, but they'll like mark it sometimes.
Yeah, for sure.
But yeah.
Awesome.
Um,
So it looks like you feel pretty comfortable with it. Do you, by any chance, could you state like the time complexity of the solution? It seems pretty optimal for me.
Yeah, I can't imagine that we'd have any better time, but let's just write it down. Yeah, so time complexity, we know because of the way that we're doing this operation, we're only going to ever look at the array a single time. 2 pointers, right? Accessing each indice in an array is O of one time. And so we have to look through the entire array, of course. So that's O of n. And then getting a max of 2 values is pretty simple as well. That's O of 1. So all our operations that we're completing are going to be an O of n time. So we know that that's going to always be there. Sorry, I got a pop-up saying I had to sign up, but I didn't have to. I closed it. And then for space, obviously for space, we're not actually going to be storing anything aside from the max, and that's just a single variable. And our input value is just given to us as an array. We don't have to do anything to change it either. Obviously, we wouldn't want to change it. So our time and space, or our time is O of n, and our space is going to be O of 1, since we only store a variable.
Perfect. Sounds good to me. Awesome. So
Awesome.
now that you have that, do you feel comfortable coding it up?
Yeah, I'd love to. I mean, I'm trying to think if I have any other questions, but I think it makes sense to me, to be honest. The uh, everything, I don't think I'm too worried. I mean, just to confirm, it looks like our output is obviously going to be an integer, so we know we're going to always just return an integer. Um, could I ask, is there ever going to be a case that the input could hypothetically be a null case or a negative case? Like, what happens if the height is empty, or if is that even a possibility, I should ask?
For now, let's just assume that you're always going to be given a valid input.
Okay, awesome. I should ask that earlier, I realized, because that could have factored into some of this stuff, but I guess that's just like edge case stuff you can check out later.
Yeah, for sure.
Um, Awesome. Would you like me to define like a function, I assume, like, a function for all of this stuff?
Yeah, you can just call it max area or
Okay.
container with most water.
Yeah. Cool. And so we'll get it passed in an array called heights, and then we'll also, I think that's what we're passed in. Yeah, heights.
Yep.
Cool. And so we're gonna start there, and then basically we had just have two things we can do prior to this. We're gonna have, I guess we can't call it max. We'll just call it result, and we'll default it to 0, just because at any point, like even if we look at our first example, there really isn't a case where we could have, according to what we just confirmed, like there's not really a case we could have anything less than the length of 2, because that's what defines an area or a box, right, where
Yep.
there's a space. So we know we'd have that. So we'll just default to result to 0, so we know it can only go higher. And like I mentioned earlier, since it's a 2-pointer solution, we need to define the bounds of our 2 pointers. So we know that the right is going to be at the rightmost and left is going to be at the first element. And we're just going to do this operation while left is less than right. And obviously we're not equaling. We never want them to equal each other, since we know that that's not in in the bounds of the box, if that makes sense, right? If left and right is here, and if right defaults to moving to left, that's not a box. One element isn't a box, so we wouldn't include that.
For sure. Sorry to
I mean,
interrupt you, but what
yeah.
operation exactly are you going to be doing?
Could you repeat that again? Sorry.
Yeah, so you just said that you're going to be doing an operation for
Oh,
these.
yeah. What I was meaning to say is, or what I was trying to say is, I was saying this while loop is just gonna execute while the operations, while this operation inside the while loop will just continue while the while loop is valid, and the operation is just moving the left and right pointers inwards, just depending on the situation we're in, or stopping if the left and right eventually cross paths, if that makes sense.
Cool. Thanks for clarifying that.
Yeah, of course. So what I'm meaning to say here then is basically we're going to say while left is less than right. And so while that's happening, we're just going to check two cases. We're going to say if we'll just get heights of left is greater than the heights of right. So in this case, we know that we want the left to move forward. and I'm actually doing this now because this is like the harder part. The not the harder part, but just like the operations of moving the left and right pointers. The actual action of updating the result will go before it, just letting you know. I'm just writing these out now because this is like to get the logic of moving the left and right.
Cool. Sounds good to me.
Yeah. So if the left is greater than that, then that means we want to move the right, of course. Or, sorry, I guess what we'll do is we'll do the opposite. If left is,
Less than.
yeah, sorry. If left is less than, then we'll move left forward by 1. That was my bad. And then that's what I mean to say here too. Where we'll do the else statement, because in this case it means that left is greater than or they're equal to. So we'll move right backwards by 1, or towards the middle by 1. Cool. So those are just like the really basic ends situations. And now it's really about just finding the area, right? And we kind of earlier mentioned that area is just equal to the base times the height. And so let's just find the base times the height. The base is really just taking right minus left and plus 1, because we know that the difference between them is 0 index, so let's just add a 1 to it to make sure we get the full value that we want to multiply by. And
Okay.
then the height is just taking the minimum of the heights at left and the minimum of the heights at right. And obviously the reason we do that is because we know that whatever one is lower is like, in a hypothetical situation, if we visualize a box full of water, the water is going to leak over whatever side's smaller. So whatever the smaller side is, that's going to be the top of the box, or like up to where the water will fill up.
Cool.
And so then we'll just say res is equal to the max of the result and of the area we just calculated.
Nice.
And so the result will always be updated at this point. And finally, once the while loop finishes, we know we can return just whatever the result returns. In our case, it'll always be 0, or it'll always be greater than 0, but we could obviously add some base cases for that. One question I just like kind of forget off the top of my head. I'm pretty sure that this is the correct value for finding the base, right? Right minus left plus 1. I always forget, like, if I add the plus 1 to it or not for this specific situation.
Yeah, I'd probably omit the 1 just because we don't know how long the array is going to be. But
Yeah, I see. Actually, I see what you mean. Sorry, I was just doing the calculation in my head where it would be, for example 1, we see that 8 to the 7 at the end is 1, 2, 3, 4, 5, 6, 7, 8 long if you include the 1. But if you don't include the 1, it's just going to be 7. So it's 7 times 7, and that's 49. You're right.
yeah, awesome. So, well, it looks like since we just ran through that, do you mind running through your code on that example test case? Let's see if it verifies the correct solution.
I'm just gonna do the operations up here, actually.
Cool.
So let's just write out the result real quick, which we know is going to be equal to 0, and at least at start. And then we know that right and left are here, right? So in our case here, what we're going to do is we're gonna default result to 0, and then we obviously initialize left and right. And so now our operations are gonna happen within this while loop. We're going to define the area. So the area is actually whatever the minimum one is. So we know that the minimum is 1, right? And then we're going to multiply that times whatever the difference between right and left are. So let's see. We know it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 to start with, and then that's 0. So it's 8 times... which is 8 minus 0, which is just 8. So it's 8 times 1, so that's 8, right? We know the current maximum is going to start at 8. And then we know that our if statement down here says if the height of left is less than the right, then we're going to increment the left by 1, which we know is true, so we need to increment left since 1 is less than 7.
Cool.
Our next operation is going to say that we have 1 minus 8, right? So that's 7. Because this maximum is 8 right now. And so we get 7 which is our base, times our minimum height, which is actually our right value now, which is 7. So we'd get our 49 that we saw earlier, right? And just for the sake of going forward, I guess we can continue our operations, right? We'd say we'd move this in by 1, which is 7 now. So 7 minus 1 is 6, right? So 6 times 3, which is 18. We know that's not the maximum currently, so we're
Yep.
just going to keep moving in by 1. This potentially, right, if the 7 wasn't out on the right side, this potentially could have been our largest value, right? So we'd be at 6 now, and 6 minus 1 is 5, and 5 times 8 is 40. So 40 could have been our largest value if we didn't have this 7 at the very end of the array, which made a larger area.
Yep.
And so this is kind of our situation where we check to see, does our else statement make sense, right? If left is less than the heights of right, well, we know that 8 is not less than 8, it's equal to. So our else statement would run where we'd know our right would get incremented inwards. And again, we'd get a situation, we have 8, 7, 6, 5. So we have 5 minus 1, which is 4. So 4 times 4 is 16 on the inside. And we just continue moving forward because we know that 8 is actually the maximum currently. Obviously, the code doesn't, but, we ourselves would just move forward.
Yeah.
And so we get to the point where we know that 49 is actually going to be the largest value amongst this array.
Awesome. Perfect. Yeah, looks good to me, and it looks like this is like the most optimal solution. I can't really see any optimizations. Yeah. Great job.
Awesome. Man, I really appreciate it. Yeah, this is fun. I don't know if you have any more follow-up questions or anything else that you were thinking of.
Not really. This is a perfect satisfactory solution.